Okay, now we come to the type of problem that almost every student is afraid of at the beginning of math, and that's word problems. But I have to tell you, word problems are the way that everything in life is defined, starts out as a word problem. Word problems are what engineers spend their entire life solving because word problems define a situation, and we have to extract information from the word problem. So you need to get comfortable reading a problem several times to extract information. And that's where being a little bit structured in the way that we read and what we do comes in. So when you're reading a word problem, first read the entire problem through, all the way through, to get a sense of what's going on. So a monkey jumps from a branch 35 feet to the ground below. In the first second, the monkey falls 16 feet. So if I have this on a paper in front of me, what I'll do is I'll read it a second time and I'll underline important information. So 35 feet to the ground. That's one big important piece of information. The first second is another, and 16 feet. I would recommend that you have a sheet of scratch paper in front of you when you're reading word problems and you extract the important information. Write it down. So the distance to the ground, okay, so the distance to the ground is 35 feet. Falls 16 feet in 1 second. Get comfortable getting the information out of the word problem and separate it from the word problem. Make it into something that you can go back to and easily look at when you're doing other things. Now on the CAASSP test, they're going to ask you to make statements about something being true or being false. You have to go back and say, this is false because this is the wrong number, or this is the wrong math based upon the numbers that I saw in the word problem. So start by reading the word problem 2 times. The first time, just read it to get a sense of what's going on. The second time through, extract the information that you get from it. In more complex word problems, you may even want to draw a picture so that you have your monkey up on the branch, the tree, and then falling down, and their position at 1 second. Here it was 35 feet, and then it fell 16 feet in 1 second. If you can draw a picture of the word problem, it will make much more sense to you. Okay, let's look at how we're going to go about creating an equation that allows us to solve a word problem. First thing we're going to do is we're going to read it through 1 time, and we're going to try and understand all the different things that are going on. So, John and Shannon are making cookies for a fundraiser with the goal of making 20,000 cookies. John makes 100 cookies per hour, and Shannon makes 25% more cookies per hour than John. They ask Ann to help to finish faster, and she makes cookies 30% slower than John. Write an equation to calculate how long it will take to make the cookies. All right, so let's go back through and read it, and we're going to underline important information. First of all, John makes 100 cookies per hour. All right, so that's kind of like the thing we're going to reference everything else to. Shannon makes 25% more cookies per hour than John. And then Ann makes cookies 30% slower. So let's look at the total production that we're going to get. We're going to get 100 per hour from John, right? So I'll just put a J above that. We're going to get 100 times 125%. So 25% of 100, 0.25 times 100 is equal to 25, but that's plus, that's over what John makes. So Shannon is going to make 125 cookies per hour. All right, so John does 100 per hour, Shannon does 125 per hour, and then Ann makes 30% slower than John. So she's going to be 30% 0.30 times 100 is equal to 30. So 100 minus 30 is equal to 70 per hour. So Ann makes 70 per hour. So our total production is going to be the stuff that John makes, the stuff that Shannon makes, plus the stuff that Ann makes. So we've got 100 per hour plus 125 per hour plus 70 per hour. So our total output is going to be the sum of those. 225 plus 70 is 295 cookies per hour. So our final equation is going to be 295 H equals 20,000 cookies. That's going to allow us to calculate how many hours it takes to make those cookies. Every word problem that I've ever run into as an engineer, I have a starting point where there's one piece of information that everything else references to. In this case, in this problem, it's that John makes 100 cookies per hour. That's the key piece of information. Everything else relates to that, either as additional output as a percentage of what John made, or as negative output. So how much less did they make than John? But everything goes back to that. Every word problem starts that way. There's a critical piece of information, and everything is related to that, and you have to write an equation where you're adding or subtracting things from that initial quantity. Okay, we're back to word problems, and we're looking at a very typical word problem that you see all the time because it forces you to put things into an algebraic expression to solve it. So let's look at the problem. We're going to read it through once, and then we're going to go back and underline the important information, and then we'll see if we can formulate the problem. The school is buying coats to give to poor children in need of a warm coat. There's a total of $230 available to spend. Large coats cost $25 and small coats cost $18. A total of 10 coats are purchased. How many of each size were bought? Now, let's go back and reread it. The total of $230 is important. Large coats are $25, small coats are $20. 10 is the total number of coats purchased. So let's start by saying that we're going to let the large coats be L. All right, so the number of large coats is going to be L. Then 10 minus L has to be equal to the number of small coats because there's a total of 10. All right, now we know that each large coat costs $25, so we can put that in. We can say 25 times the number of large coats, L, is going to be the amount we spent on large coats, plus 10 minus L times $20, because the small ones were $20 each. And finally, we know that this number, how much we spent on large coats, plus this number, how much we spent on small coats, is going to be equal to $230. Now, let's do the arithmetic to get this. We've got 20 times 10 minus L, so we're going to multiply this out and rewrite the problem. 25L plus 20 times 10 is 200 minus 20 times L, 20L, equals 230. Well, now we can start moving things around because we have 25L and a negative 20L. So when I add that together, I end up with 5L plus 200 equals 230. Now I'm going to subtract 200 from both sides. That knocks that out. And now I've got 5L equals, and 230 minus 200 is 30. All right? And finally, we're going to divide both sides by 5. So L is equal to 30 divided by 5, which is 6. So we bought 6 large coats. Let's see if this makes sense. So 6 times 25 equals 150. And then 10 minus 6 is 4 times 20 equals 80. 80 plus 50 is 230. That's exactly how much money we spent. This is generally how you're going to set the word problem up. You're going to assume one of the things that you're looking for is the variable, in this case large L for large coats. The other is the total minus the variable, and then you do the costing. I hope this helps you.